And we're off. Hello, dearies. Welcome to Undersampled Radio. What's the name of the show? Undersampled Radio, episode 54. We have a very special guest today. We also have Matt today. But we're going to do something crazy. Let's kick it off. Let's kick it off with Riddle Me This. I'm pretty excited about this riddle. And Matt and I just read through it. So before it slips the old brain, I'm gonna introduce it to you. Here we go. You ready?
Yes.
He just edited it just 3 minutes ago. Okay, you have N users on a patrol project. This could be done with any amount of users. Each one has interpreted a seismic horizon. The name of each horizon is dsand _ pre-stack _ final _ January 2017 _ final _ X, where X is the author's number out of N. So the X's exist in the set 1 to N inclusive. Last month, the project was corrupted, and the only backup is stored on Univac tape reels or chiselings in stone tablets or some other equivalent medium. One at a time, each of the users enters the data tape room, and is allowed by the system's admin to read only half the tapes. So what's that? N/2 tapes. And is forced to put the tapes back in the order in which she found them. After each user enters this backup tape room, they quickly shuffle back off to their cubicles and aren't allowed to speak with the other users. No collusion here. If one of the users can't recover their respective... Oh, I'm sorry. This is the part he edited. If any one of the users can't recover their respective horizon files, they will all be fired. If, however, every single one of them recovers her own horizon, they'll all be allowed to keep their jobs and upgrade to OpenDTech next year. Okay, so here it comes. Though the users can't collaborate during the data reading, that's a consequence of being shuffled into and out of this data room and back to the cubicles. They go out for a beer the night before. They all go out together and have a strategy meeting. So the question is, what's the best strategy they can come up with to save their jobs? And what's the probability of them making it to the upgrade next year?
Question.
Yes. You in the plaid shirt.
Thank you, sir. The tapes are randomly ordered?
The tapes are randomly distributed inside of the file room, yes.
The tape room, yeah. And the tapes are not labeled?
Whatever. We could just say the tapes are labeled 1 to N. How about that? Yeah.
So my strategy can't just be reading the label.
Wait. I know I messed up. Sorry. This is due to 4 weeks of time or something since I wrote this until I'm reading it now. Disclaimer: I didn't actually write this riddle. I just obfuscated this riddle. No, the tapes are labeled. Sorry about that. And they're labeled. They are labeled 1 to N, but they are randomly stuck on the shelves in the tape room.
Okay.
Yeah.
So these labels do not correspond to the users, or they do correspond to the users?
The labels do correspond to the users.
Oh, but they're only allowed to read the labels on the of N/2.
Right. Okay. So there's file names, let's say, on the tapes, which are labeled with the user's labels.
I understand.
And they're just sitting on the shelf with little pieces of tape on them that say whatever 1 to N.
Right, but they're only allowed to inspect the labels of N/2 tapes.
Indeed, they're only allowed to read.
Yes. Okay.
That riddle could have been given in a much more concise way.
I'm also wondering what happens if N is not an even number.
Yeah. Okay.
To rule, but let's say it's even.
Let's say it's even. Good thing we're professionals at telling you riddles. Okay, so if that riddle wasn't just oblique enough to follow. Let's hope that we have some submissions, because it's actually a very cool solution. And next week, when I give the answer, I will actually say where the riddle came from, so you can hear the non-garbage version that I just told you. You want to do news, Matt?
Very good. News, yeah, the hackathon that I keep talking about next month in Houston.
Next month
is I already told you that it's sold out, but now it has also has a full complement of sponsors, like actually turning sponsors away. So that's never happened before, and it's pretty cool. And one of the sponsors, Pioneer Natural Resources, is an operating company. We did partner before with Total, but we didn't have an oil and gas company before now, other than that occasion in Paris, support one of these events. So that's really cool too.
Here's my question to you. Why not just take another sponsor and get yourself a nice boat?
Well, if we've got excess sponsors, I'm immediately trying to push them off into the next event so that I can, like, isn't that called front end loading? Something, so that I can get ahead of the sponsorship train on the next event.
I just call it the antithesis to sailing, but whatever.
I don't think hackathons are a commercial venture of ours. That would feel weird, but maybe one day I can get a boat. I wouldn't mind just a tandem kayak. If anyone's got a secondhand used tandem kayak for sale, I am actually interested in buying one of those. And if someone wants to sponsor that, that'd be great. It's about $1,000. So, just put that out there. You can have your logo on the boat if you wish. But that's it, really. Do you want me to talk about these other things? They're not very.
Well, I'll mention the one you put a link in the show notes, which is kind of cool. It's just some crazy volume comparison of various mined minerals to cities and things. It's actually just a cool graphics. Take a look at it for 2 minutes. It's wonderful.
Yeah, it's pretty cool. So yeah, he's a photographer, and the one that caught my attention was a photograph of copper mine. So you know what those often look like, these very deep tiered holes, massive hole. Obviously massive trucks are driving up and down inside this thing, and he's computed the total, found out the total volume of copper mined from that facility, and then 3D rendered a blob of copper representing or corresponding to that amount, sort of sitting at the bottom of the mine, like this giant kind of ball of metal. And it just looks spectacular. A just looks really cool and shiny, with a shadow and everything. But B, it's kind of remarkable how little of it there is compared to the size of the hole it came out of. He's done the same thing for some gold mines and some like nickel mines, I think, and some diamond mines. And that's kind of cool because there's a photograph of the diamond mine in some kimberlite pipe in South Africa or whatever. And then he has to zoom in on the diamond that's the equivalent number of carats that have come out of that mine, because you can't really see it in the photo, right? It's tiny. So yeah, it's kind of a neat visualization project.
Go check it out. Links in the show notes. I'm gonna work the I'm gonna very secretly try to work the Excel CSV data handling conversation into our conversation here, but don't tell anybody. Hey, do we have a guest this week?
We do have a guest, actually.
Who is it?
I'm glad you brought that up. You can see him sitting down. Well, if you're watching, you can see him sitting down there in his little square at the bottom of the screen. That's Elwyn Golloway. He's a geophysicist in Calgary at the AER, the Alberta Energy Regulator, previously called the EUB and the ERCB. Am I getting all of those right?
So far, so good, yeah.
So the Energy Regulator in Alberta. And I met Elwyn, I think the first time we met was at the hackathon in Calgary, right, in 2015.
Yeah, I think that was the first time.
Yeah, so a couple of years ago. And basically since then, we just stayed in touch on Software Underground and maybe Twitter a bit and that kind of thing. So welcome, Elwyn. How's it going?
It's going great. Yeah. Thanks for having me on. You know, a long-time listener, first-time caller. Just, yeah, glad to be on here with you guys.
Awesome. Yeah, welcome. You're in Calgary right now. Are you at work?
I am at work. I work in the Alberta Geological Survey office, and that's in Edmonton. So though I live in Calgary, I work in Edmonton. Yeah.
Oh, wow. Beg your pardon. So what are you commuting like weekly or something, or how are you doing that?
Yeah, for most weeks, come up on Mondays and drive back to Calgary. It's about a 2.5-hour drive. But most of my work weeks are 4 days, and yeah, it makes it all right.
Yeah, that sounds great. Yeah, it's pretty easy drive up, isn't it? It's called the Queen Elizabeth Highway now or something?
That's right. Yeah, the QE2 as they call it around here. And yeah, if I ever got an automated driving car, I think I'd really enjoy my drive a lot more.
Yeah, it's good. Weren't they talking about putting a train on that up, like, you know, on that route basically at one point?
Yeah, it's funny that comes up. That idea gets floated around every 5 years or so. You know, a high-speed train, or maybe it'll be a monorail the next time. But yeah, every time they do a feasibility study, it ends up being too expensive to justify.
Yeah, right. I guess, yeah. I always wonder how they, how those cost justification things work, you know? Like, what are they taking into account?
Right.
Like people's time, accidents. Like, I wonder how they do that calculation.
Yeah, I imagine they have, I don't know, maybe they look at what's been going on in Europe or Japan in terms of rail usage and how that's spawned, I don't know, development along the rail corridor or something. But yeah, factoring all those things in would be pretty difficult, I suppose. Yeah,
I guess that's the thing. In places like Japan and Europe, you've often got, I don't know, I'm guessing that the passenger rates must be 10 times what they would be between Calgary and Edmonton. So do you ever fly, or you're driving?
I drive. Yeah, it's a choice I've made to drive. So it's not that the company's springing for that, or the organization. So yeah, driving for me is that's my choice.
Yeah, right.
Yeah, well, soon it'll be a Hyperloop or a Tesla 3.
Yeah, there you go.
Nice.
Or teleportation.
Okay. So Elwyn's got a blog called Cybatical, which is pretty awesome. How did you get into blogging?
Blogging. Well, I found some time between employment with an energy company in Calgary and before I started here at the Alberta Geological Survey. It was a way for me to, flex my intellectual muscles. And, I was inspired in part by Agile's blog, as well as Matteo Nicolai has his My Carta blog. And yeah, I really liked, reaching out, telling some stories, so to speak. And it was, an issue of finding topics that were interesting for me to write about, and little projects that I could learn something new along the way.
What's your favorite side project? There's a couple of cool ones on there.
I guess the one that came out of the hackathon in Calgary was probably my favorite for a number of reasons. It's been great to write about on a few different topics, from different perspectives. It was also, I guess, the one that really kicked it off for me in terms of thinking about how I could share what we'd accomplished at the hackathon.
That was a sketch to model, right?
Yeah, that's right. So sketch to model, during the Calgary hackathon, we came up with a web app to, I guess, digitize a sketch on a whiteboard or a napkin or sheet of paper into a block diagram that could be used for presumably Model R, which is Agile's seismic forward modeling software.
Yeah, we've been totally delinquent on Modeler, unfortunately. But yeah, in fact, I think it works, right? At the end of the hackathon, you could actually pass a model to Modeler and get it to model something.
Yeah, the final demo at the hackathon, it wasn't completely live. We weren't confident enough for that, but right. Yeah, it was a working app that we could use. Afterwards, the teammates and I, so Matteo and Evan Saltman, we continued developing it and working on it over 6 or 9 months afterwards to refine the process and get it to a more robust algorithm, I guess, to be able to handle more and more different variations in Sketch. So learned a ton from Matteo and Evan as well. Evan was more of the web app expert, and Matteo was the image processing guy. So we pulled it all together, and by the end of the hackathon, we had something that was pretty much a working product.
All I know about it is that you draw some cool thing on a piece of paper, which maybe looks like geology or maybe doesn't, and it spits out an Earth model for you at the end. How does it work?
So, I mean, there's some interesting blog posts you could read about on my blog, but essentially you take the image, which would be a color image from a smartphone. That seemed to be the use case we had in mind. Take a picture of a sketch, whether it's on a whiteboard with markers or on a piece of paper with a pen, and it binarizes the image. So it turns it from color image into black and white. And we apply some morphological filtering, which joins up lines where lines should be joined up in case you accidentally left a gap, and doesn't join up lines that we don't think you intended to. And from there, it segments the image into different blocks, and those will be the blocks in your Earth model. And then it spits out a PNG image where each of those blocks is then given a different code or color.
Yeah, nice. And basically that's what Modeler uses internally as a sort of starting point for an Earth model. It just has a mapping from colors in the Earth model that you give it to rocks and their elastic properties, and then you can forward model them, forward model the image as if it were an Earth model, essentially.
So the whole thing.
Yeah. So the idea behind it was to instead of coding in a wedge model or something slightly more complicated, you could sketch it out by hand and quickly get it into Modeler and see a forward model, ideally within seconds. So if you're working with colleagues in a boardroom, sketch it out on the board, and with your smartphone or iPad or whatever, have a demonstration of what the seismic could look like for whatever geological realization you might have in mind. And so you could do that quickly for one or draw a dozen different geological realizations and quickly see what difference it would make in the forward modeling problem.
Yeah, right. Yeah, it's cool. And what I really loved about it was that it was the first time we'd had in a hackathon someone picking up the API for an existing tool that had sort of come out of our community and trying to use that as part of their solution. So actually pulling different web APIs together. And I'm trying to think off the top of my head if we've seen any more examples of that. Actually can't think of any, but I feel like that's partly our fault for not being too awesome at documenting these APIs. But that was part of the my hope with the hackathons, was that we'd see eventually a sort of ecosystem of these microservices that do things like model generation or forward modeling or inversion or attributes or whatever. And I think slowly that's sort of coming to pass, but it takes a bit of push and pull, like it's one thing to build these things and put them out there, but you also need users and use cases and people to help you drive the development. And we don't have a culture of that yet still, right? You'll be lucky if you have a couple of dozen users kind of thing.
Mm-hmm. Well, this is a big one. I mean, the workflow the workflow that's put together by the two pieces, Modeler and Sketch to Model, is much more geo friendly than, as Elwyn mentions, some programmer like putting a wedge model or whatever, like putting in binary floats into places.
Yeah, right. Totally.
I really love the idea. I think it's awesome. And it's fun just to go play with it. I put a link in the show notes to the website, and it's still up right now. You can go have fun. So Elwyn, what do you have? You have 2 bachelor's degrees?
I do, yeah.
Why? That's awesome. That's awesome. What possessed you to do that?
Well, I coming out of high school, I loved physics, and so I registered in the physics program at the University of Alberta. And it was admittedly partly out of spite that I didn't get into engineering. My friends were trying to convince me to go in with them, and I flatly refused. I don't regret it. So went through the physics program, and upon graduation, set out into the world to find, my career, my job. And I quickly realized, if somebody who's looking for somebody with, problem-solving skills, strong math background, they're actually looking for engineers generally. So didn't find much appetite for physicists out there. But an uncle of mine who worked in the energy industry wondered if geophysics and physics might be related enough for employment. So he set me up with some of his colleagues in industry just to chat about, hey, what is geophysics? And after speaking with them, decided I'm going to go back to school and get a geophysics degree so I could work as a geophysicist. Now, for me, the courses at University of Alberta for physics and geophysics the programs are very closely aligned. So I found that I had a lot of the prerequisites and courses that I needed. So it didn't take me long to achieve another bachelor's degree, and that was what I felt was the fastest route for me to get into a career.
I see. So right, because I don't know how many universities do this, Graham, but the U of A in Edmonton is the only place I think I know of where the geophysicists are basically in the physics department.
Awesome.
So Evan's a graduate of the U of A as well. What was I going to ask? Oh, so once you've used a course for a degree, you can still use that course to as a requirement to fulfill requirements for another degree, can you? Yeah.
So the University of Alberta has some guidelines on achieving second degrees, and I think you need at least 10 courses worth of credits to achieve a second degrie. So I think I needed 11, so that worked out pretty nicely for me.
Awesome.
Yeah, that's really cool. I mean, I think it's a really good path into geophysics. I think physics. We've worked with a few physicists. You got a physics background, haven't you, Graham?
Well, I don't really want to go on a rant per se about geologists becoming geophysicists, but I will just say, learn your math, folks.
Yeah, I mean, it's a tricky one, isn't it? Because, if you talk to Chris Jackson, he wrote an essay for us once about how the first person to see a seismic data set should be a geologist. And whatever, you could, I think it's perfectly valid to argue that there shouldn't be a distinction between geology and geophysics like we make, but there is a distinction, or at least there's a spectrum, right? And there are geologists, more or less pure geologists, who are doing geomorphology and use geological analogs in their heads for the shapes of things that they see in seismic. And then at the other end, there are people who kind of see coherent noise signals and are doing Fourier transforms in their heads when they look at seismic, and obviously you need both of those people to see seismic data to decide if it's valid and what you can learn from it and what it means quantitatively and all that sort of stuff.
So we should encourage the U of A to make their geophysics program degree 6-year bachelor's degree where you have to learn math and geology.
Yeah, I don't know. It's a tough one. I mean, there's probably you could probably count on one hand the number of people who have enough background at both ends of that spectrum to interpret seismic on their own. Mm-hmm. Geologists can't tie wells. You're right. I mean, that's impossible and dangerous, I would say. But you also can't tie wells just on the basis of signal processing.
Yep.
Like, so I mean, it's an interesting. I guess it's one of those fun kind of debates you can have about your profession.
Well, I'm glad that we've now offended
anywhere.
both halves of our audience.
No, I mean, yeah.
Yeah. Yeah, no, that's I like the idea of the spectrum of perception, right, based on background.
Because I think all this is just a really great example of, you know, why working on a multidisciplinary team is so powerful, because
indeed
you can lean on everybody else's experience, whether it's, you know, working in different areas before, or, you know, working on projects where you had to use pre-stack inversion to really make things work. I mean, it's a great chance to progress a project, but also to learn. And you know, you know, we talk about mentorship and things in our discipline about, you know, find a young geoscientist and mentor them. But I mean, to me, it's as important to mentor people who are more experienced than you in areas where they're not as strong. I've enjoyed the mentorship of a vast number of people in my career so far, and I've had the pleasure of mentoring a number of people as well. So, I mean, I see the value, and I think it's important for people to look within their own discipline, but also, you know, to other disciplines as well.
Yeah. What for mentors, you mean? For mentorship.
Right. Yeah.
Yeah. Yeah. Totally agree.
I had fun doing the Intro to Geophysics course. I did a really introductory level professional development course over the course of a couple of years, 2-day course, or 2.5-day course, just with random folks that were mostly geologists, but they were chemists and stuff. And I guess is the case in any teaching scenario. You'd learn 10 times more than the students learn by putting the material together, and then the students interacting with you. It's really an enriching experience.
Yeah, totally. So, what have you got any other sort of side projects on the go now, Elwyn?
Yeah, well, some of my blog posts I've put out to date have to do with fantasy hockey. And,
yes, I was going to ask you.
Hockey drafts. And, yeah, so I have a project ongoing with I've recruited a couple of my friends to work with me.
So this is just for those of us who don't follow these things. This is hockey, but with sort of witches and wizards.
Not so much. I mean, people are maybe more familiar with fantasy football or fantasy soccer or something, but essentially you draft a team of players, and their results in real life affect your pretend team. So you can mix and match players from different teams, and their production on ice affects.
It's connected with their performance in the real world. That's cool.
Right. Yeah, and it'd be a fantasy to pull these teams of really great players to play on one team. I guess that's the fantasy aspect of it.
Right.
So the draft is going to be coming up, next few weeks, huh?
Yeah, the start of the season's coming up, and in preparation for that, my friends and I are trying to apply machine learning to predict the performance of the players over the year. So this would be my first true machine learning project. So things are crunching along slowly, but
this is awesome.
It's been it's a fun way to learn something new, that's for sure.
It's money ball, well, money puck.
Yeah, in a way, sure. Yeah, so understanding which players might offer you the best value in terms of, in our league, I guess the cost of the player would be how early in the draft you pick the player. We take turns picking one player at a time from the list of available players. So if you spend one of your early picks to pick a really good player, then it's more costly than a pick later on.
Right. Is the analysis? Well, maybe it works on both things. Is the analysis for like draft strategy, or is it for full season strategy with trades and bench sits and stuff? Right.
This machine learning problem right now is about trying to predict what the player would do for the full season. So, will Alexander Ovechkin score 50 goals next year, right? To come up with some prediction of their productivity in goals and assists and some other stat categories as well. So trying to look at that player's previous production, maybe look at what other players playing that position have done. Players as they mature and age, their productivity changes. So early in their career, it's lower. There's sort of a peak, and then it tails off. So my idea is, if you throw a lot of information into it, maybe you get something viable that comes out. And I realize that's fairly naive, but we'll start with that assumption and see what we have to do to come up with some predictions.
My question wasn't good. What I meant to say was, is there like a time series component to it? So, for example, yeah, during the draft, you want to pick the best players, highest predicted points. But during the season, you want to know, maybe this player performs really poorly in the past 7 seasons against team X or whatever. Is there sort of like a temporal component to the prediction, like as the season progresses?
Yeah, so the project that we're working on, we're just trying to do, season as a whole. But
Sure. Yeah.
In other sports, I've certainly read about people who've tried to do that for what's very popular the last few years, which is daily fantasy sports, where people are picking a team for one night, and so the production on that night you dictate your winners and losers in the fantasy pool. And from what I understand, there's a lot of data scientists that have made some significant money in that by analyzing the right picks to make and actually picking a vast amount of teams. So submitting a large number of teams that have a better chance of capturing the prize. I don't know anything about fantasy hockey, but in fantasy football, there are people who pay, like consultants, like fantasy football and draft consultants, who you've got to pay $50,000 to, at like a retainer, just so that they help you with your picks, they help you during the season, all this stuff, because it's big. So this is your next career, Elwyn.
Wait. Just a minute. These consultants are working for fantasy football people.
Yeah. So there's big money pools.
Okay.
So there's public pools.
Prize money for doing well in these leagues.
Yeah, indeed. Yeah.
Where does this money come from?
The entry fees from all the players.
You have to pay. Okay, I see.
Yeah.
Yeah, the leagues I'm involved in, the prize is more pride than money, I think. We do have an entry fee, but I mean, for a lot of guys, if you cost out the time or the reward per hour
don't do it.
spent.
Don't do it. No, I think the prize is no longer just pride. It's status amongst the data science fantasy hockey elite.
Yeah, there you go.
And a job position, maybe.
Maybe someday. Yeah, the interesting thing will be to compare whatever predictions we can come up with against some of the other predictions out there. There are a number of sports magazines that put out predictions every year for some of the top players. So that's part of, I guess, QCing what we're coming up with. But also, if we can outperform their predictions, then I'd take that as a pretty big victory for me, anyway.
So I don't want to steal your secrets or anything. Yes, I do. But what kind of architecture are you using, and how are you performing your analysis?
Right. So this is pretty early on, but well, I haven't got very far yet, so I don't mind sharing. There's not much secret out there, but right now I'm using Python. That's my language of choice for all my projects. And well, I was using, what is it? It's long short-term memory. Apparently it's good for time series predictions, so that's what I've been trying to apply. So maybe you guys can offer some advice on this.
Well,
I think you need to hire Graham as a consultant.
It's only 50
time right now.
It's only $50,000 worth of per team, so per participant. I have worked on, and I am working on LSTM regressor problems. And we can compare notes sometime. But I'm like in theory, the problem is really simple. You just stick the input, you just stick your feature vectors on the front side of it. A really simple network. It can just be like a linear layer or an LSTM a dropout layer and a linear layer. And then out comes your $50,000. But in practice, it's a lot more difficult than that. It takes a lot of, like, feature engineering is tough to do because you have this temporal dependency. And if you want to do like multi-dimensional input, which I assume you do want to do, then you got to somehow statistically weight your features to make things fit nicely. So I'm excited to see the next blog post in which you unveil your project. But yeah, there are a couple, I think there's 2 posts up already, right? About it?
Yeah, for the fantasy hockey. Yeah, neither of them have anything to do with machine learning.
Yeah.
But, this latest project, it's sort of been coming along through the summer. But like you said, the draft is coming up in a few weeks or a month or so. So that doesn't leave a lot of time here. So not sure if I'll have a chance to get the blog post out before the draft. But yeah, certainly something on my radar to get out there.
So in the blog posts that are up, you mention a lot about a Python toolkit called Pandas. Why Pandas?
I think I found Pandas essentially because I wanted to make a nice display of a table. I mean, Matplotlib has a lot of graphs and things, but I didn't have a nice way to display a table of results. So that's initially why I found out about Pandas. But it does have some nice functionality in terms of handling arrays of data. Yeah,
reading CSV files is easy. Maybe even Excel files. What do you think about that, Matt? Drops like on stage.
That was smooth. Yeah, absolutely. It is. I've said before in this show that I'm very aware of Pandas. Seems to be really awesome. Do use it for some things, but I've never quite got my head into the Pandas world well enough to kind of really wield it. I find doing something like I just want that value, or I just want to change that thing, and I get warnings or weird results, and I've never quite got over that kind of hump. So I generally use it. I generally try and get into an NumPy array as quickly as I can. But yeah, I can't remember quite where it came from, but there was a conversation on Software Underground a few weeks ago about Excel, and it went between Lucas Mosser and Steve Purvis. It ended up with something along the lines of, if it's possible to do something in Excel, then someone has done it in Excel. So I think we were talking about probably reservoir modeling or flow simulation or something like that at the time. But, and obviously there's lots of Excel files floating around in all companies. And I've seen Reservoir Engineers Excel files, and they are something to behold. And I've said before on this show too, but I'll just reiterate, if you do use Excel and you ever get the opportunity to sit next to a reservoir engineer while they're using Excel, I guarantee you will see things that you didn't know you could do. Like they got Excel superpowers. But it prompted me to write a blog post about how maybe Excel is used for too many things, based on this, what Lucas called Murphy's Law of Excel, the kind of what you can do will be done. And just mentioning that there's stuff like Tableau and Spotfire for time series analysis, especially for people like reservoir engineers, who should definitely be using Spotfire, in my opinion, or Tableau, which I don't know, but Spotfire is awesome. There's R and Python out there. There's Google Sheets, which personally I prefer over Excel, but there's other options, and maybe sometimes they're more appropriate. And then I wrote a blog post about, if you are going to keep data in Excel, then at least make it machine readable. Because, I mean, people do awful things inside Excel spreadsheets with like weird table headers or random empty columns, or columns containing a mixture of data types, or footnotes, or things that are color coded. So if you tried to read them with Python or R, you wouldn't get very far, basically. So I wrote a whole post about that. which prompted some people to comment with some other much better resources on how to organize spreadsheets. One of which was written by like one of the devs on R, so it's totally legit. And then I followed it up with like, okay, here's how to read CSV files in Python. Using pandas is the easiest way, basically. But there are some other ways to do it, and I go through them in that post. So 3 of my last 4 blog posts have been about spreadsheets and CSV files. And I just wanted to mention that because I don't know why, but they've had lots of comments and been shared around a lot, so they've obviously struck a bit of a nerve. But I feel like it's one of those things that even when you start hacking around in Python, you're like, okay, this is great, I can do some math or whatever, but where am I going to get data? Like, how do I do stuff on my numbers? You know, my numbers are over here in this file. Like,
there's still a learning curve to both pandas and Python, but it literally is as minimal as it gets. And if you haven't tried, it's, what is it? PD read CSV.
Yeah.
One line and your data is in.
Yeah.
And then you can do things in Python like, you know, whatever.
You can go do your time series analysis or your
just
math.
Yeah.
And then you can write it out again, one-liner.
Yeah.
Yeah. If your CSVs are nice and clean and properly formatted, and there's a tool actually on the web called CSV Linter or CSV Lint, one of those. It's like in a CSV integrity checker, and it sort of gives you like warning lights if things may be formatted incorrectly or might give you problems. And if you've got good CSVs, it's seamless. The problem is that most Excel files, in my experience, you can't just save them as a CSV and have joy. You'll be like moving rows around, deleting rows, changing columns.
So the other reason I bring up the blog post thing is that earlier on in the blog, Elwyn, you did some financial modeling in Google Sheets, and then subsequently moved into the Python Pandas regime. So I guess first just give us a brief overview of the financial modeling thing, and then tell us how much more awesome it was in one version or the other.
Sure. Well, yeah, I mean, I'm by no means a financial advisor or anything, but essentially one of the things I experienced in my life was getting into the real estate market by buying a home, and you know, quickly realized that sure, I'm not paying rent to anybody, but you know, I'm kind of paying rent to the bank. So that made me start to question, you know, was it really a better idea to buy something rather than rent a home? So yeah, after giving some advice, cautionary advice to friends to, you know, think about or consider it, decided to make a tool that people could use to, you know, compare buying a home versus renting a home, and maybe spending the difference on investments, or investing the difference between the two financial scenarios. And yeah, so I built a tool, and it's, you know, there's a bit of a story around it on my blog, and the sheet exists on Google Sheets. And yeah, I mean, in my experience, the Google Sheets was, I mean, it's convenient for sharing. Certainly, people can find it and hack on it if they want. But I found, you know, simulation or running scripts on it to be a bit slow. And some of the functionality you take for granted in Excel, which I was certainly not a reservoir engineering power user, but you know, had a few tricks up my sleeve. I missed some of those tricks in the Google Sheets. So yeah, it was, I don't know, I wouldn't tell people not to use Google Sheets, but it's a different experience, right?
Yep, sure is.
Yeah, exactly. And I suspect, you know, I only have the Excel like desktop application. I like probably in Office 365. I'm guessing that a lot of the cool online stuff that Sheets does, and the sort of version control and file sharing and all that, I assume is in Office 365. You know, it's cloudy. So, I mean, I suspect many of the advantages from Google Docs are really just from my familiarity with that environment, right?
Well, before we run out of time here, I just want to ask you, scientist types, how was your eclipse experience?
Ah, yeah. How was it in Calgary, Elwyn? Because it looked pretty. Calgary, what percentage was the eclipse there?
Yeah, I think Calgary got
sorry,
up to...
you were in Edmonton anyway.
Yeah, I think it was 80 or 90% maybe.
Whoa, okay.
70 or 80, something like that. Anyway, it's pretty cool. I mean, you definitely noticed. You walk outside and it's dimmer. I felt like I was wearing sunglasses outside, even though I wasn't. I did have eclipse glasses though to look at the sun. And there was a number of us outside the building. Stood around for 20 minutes or so, admiring the celestial event. How about you guys? Did you guys catch any where you are?
Yeah, it was about 75.23% total here. I unfortunately had a call at max totality, but I went out about 10 minutes before and took some shots through the old Google glasses thing, the little sunglasses. Absolutely fascinating. The highlight of the experience for me, not being in the totality plane, was just thinking about how many people are out there watching this celestial event. I mean, it's amazing. It really is, one of the few scientific fascinations that's unescapable. Not just easy to access, but you're gonna see it if you're anywhere near it, and people love it. How about you, Matt?
Yeah, so we were only about 55% here in Nova Scotia, but it's the first eclipse I've experienced, like solar eclipse that I've experienced, because I think we were in Norway for the 99 one, which was also, I think, partial in Norway, but it was the weather was crap, so it wasn't anything to talk about. And my favorite thing was the dappled sunlight under the trees. I just love that, with the little crescent-shaped spots under the trees and on the sides of buildings with the sunlight coming through the trees. I love that. So, but I did try the colander thing. That was also quite good.
I saw that. Your wife posted an Instagram post of your colander picture.
Oh, she did? Okay. So one of her friends posted a funny comment, which was, "I hope he didn't strain his eyes."
Oh.
This is quite good. Yeah. And anyway, it was, so the weird thing was, like, a few of the people here in the hub humored me by looking at the colander or whatever. I was walking around my home bay
with a colander.
Yeah, I had my colander and my phone. I was trying to take pictures of stuff, and I was, anyway, it must have looked like a bit of a weirdo already. But then I felt like a weirdo too, so I felt like I had to kind of like explain myself to random passersby. But I was trying to engage them in, like, check it out, look at these awesome crescent dappled sunlight things, and because the eclipse is happening, and people were like, cool. And nobody was remotely interested. I couldn't believe it. Like, what, have you not heard about this? Like, do you understand what's happening?
They watched the live stream on their computer. What do they need to look at it through a colander for?
I was really upset. But anyway, so yeah, it wasn't a fantastic social experience, but I enjoyed myself.
Good. Elwyn, thanks for joining us on the show today. It was a great chat, and we look forward to winning fantasy football. I mean, hockey.
Hey guys, thanks for having me on. It's been a real pleasure.
Hey Matt.
Thank you.
Hey Matt. Yeah, we're doing it. We're doing this. So, if I were an inhabitant of Mars, when would the next Earth solar eclipse happen?
Oh, that's great. Wow, that's really cool. I have absolutely no idea. I'd never even thought about planetary eclipses on other planets. Like, it doesn't occult the sun, though, does it? It can't do. Can't be. It's not big enough.
I actually don't know. I just thought of this 2 seconds ago.
It'd be nowhere near big enough. So it would just be a transit.
Right.
Oh, that's right, because the distance from Mars to Earth. Yeah.
But Mars has a moon.
Okay.
So it must experience.
Let me revise the question. Hey, Matt, when's the next Martian solar eclipse? Okay, with that, we're off. See you guys next week on Undersampled.
Bye, everyone. Cheers, Elwyn.